This image elaborate how sliding ballast tank and tailrace tank would be joined with each other. When tailrace tank is completely filled with tail water, we have to empty it and reposition under the powerhouse. We would use ballast tank technology for lifting upward the tailrace tank. We would use ballast tank technology in two ways. 1. Sliding ballast tank. 2. Conventional ballast tanks. These two types of ballast tanks would function collectively to reposition tailrace tank. We have discussed the functioning of sliding ballast tank in previous video. Sliding ballast tanks would be inflated by dropping tailrace tank's weight gravitational force. Our two main considerations are 1. How much weight tailrace tank plus sliding ballast tank we have to lift up reposition. 2. How much ballast tank's inflation would be required to lift up combined unit tailrace tank and sliding ballast tank. We have two sources for inflating the ballast tanks. 1. Tailrace tank weight for inflating sliding ballast tank. 2. External energy for inflating conventional ballast tank. Now I try to explain these points. Let's suppose the powerhouse displaces 100,000 kgs, 100,000 liters, of water. Now the weight of combined unit tailrace tank and sliding ballast tank must also be 100,000 kgs or near it to balance under the powerhouse. This is because weight of combined unit offset the water displacement due to powerhouse. Now when tailrace tank is filled with tail water, we open the bottom gate of tailrace tank. At this time the weight of combined attachment tailrace tank and lower compartment would drop downward. This would result in inflating sliding ballast tank. When sliding ballast tank is inflated, it would neutralize the dropping of combined unit. It means neither combined unit would drop further, nor sliding ballast tank could move upward. At this time lower compartments slide out, and we lock this position of both compartments by using some locking mechanism. This is time when we need conventional ballast tank. Conventional ballast tank would be inflated to move upward the combined unit. Conventional ballast tank would be inflated by using external energy source e.g. electricity. Where conventional ballast tank would be adjusted or located. We can locate conventional ballast tank at top of upper compartment, or inside the lower compartment. I believe more than 70 to 80% of ballast inflation would be gained through sliding ballast tank. When both types of ballast tanks, sliding ballast tank and conventional ballast tank, are inflated, they will move upward the combined unit. When combined unit tailrace tank and sliding ballast tank reaches under powerhouse, the bottom of tailrace tank would be closed again. This is how we would reposition tailrace tank. At this time we would connect air injector line with upper compartment and unlock the both compartments. When upper compartment is unlocked free to move, reservoir's water pressure would force it to refold automatically. At this time sliding ballast tank would refold with reservoir's water pressure. Conventional ballast tank would be water filled again at this time. Now tailrace tank is again ready to